This is a follow-up to the video I posted yesterday on these two radios where I looked inside them and talked a little bit about the circuit boards and then inside them and looked at the differences and how the chips differ between them. In this video, which unfortunately is going to involve a lot of handheld video pointing at the screen, I'm going to talk about how I think the antenna gain circuit, so I think there's an additional stage of RF amplification on this radio as compared to this one, which I think explains its good performance on shortwave, but also conversely why it overloads and this one doesn't, at least in my environment. In the second part, I'm going to look at the data sheet for the chip that's in both of these radios. And I'm going to talk a little bit about whether it could be, or whether the circuit board could be modified to change the AM or medium wave band for one that's more appropriate to North America. And I will say, I think the answer to that is yes. So apologies again for what's going to be a very talky video, and hopefully it will be of interest to somebody. I'm going to just start first by comparing the circuit boards between the two of them and talking about those a little bit. That's a video I recorded a little bit earlier. And then I'm going to have a section where I'm going to talk about how the band selection functions on these kinds of radios, and again, whether it would be possible to modify it to change which AM band it's actually selected to use. So let's get right to that. Apologies for the handheld video here and for the video of the screen, but I wanted to compare a couple of things between these boards, and I'm looking at pictures on the screen is the easiest way to do. So one thing we can note, this is the 219. This is where the medium wave antenna is coming in, the medium wave RF, right? There's a capacitor and it comes right into this pin here. So if we switch over and look at the 328, we can see it's coming in here. There's a capacitor, it's coming into the same pin. Same chip, same pin, so that's working. Let's see if we can figure out what's going on with the FM. Now, what we have here is we have a whole bunch of transistors, and the FM comes in here somewhere, and I'm not sure because it comes in on the other side of the board, and some of these transistors are operating as the RF. So this is something RF, shortwave, that looks like an M, which that says medium wave RF, short, anyway. So maybe that's where it's coming in down there. That does fit my memory. And so then we have 1, 2, 3, 4 transistors. I don't know what they could be except RF amplifiers. What else could they be doing in this circuit? I mean, one could be controlling the LED, I suppose, but I mean, that's not really necessary. So this is the 219. This is the one that overloads, and this is the one that a lot of people report has really good sort of fringe shortwave performance, or for shortwave performance if it's not in an FM overloading circumstance. Now let's go over and let's look at the 328. So the FM comes in on this blue wire, comes in here, 1, 2, 2 transistors. I thought there was a third one hiding in here somewhere, but just a couple of transistors coming in maybe to that pin there. Again, without tracing out the whole circuit, there's another transistor up here, but that doesn't appear to have anything to do with that. I bet that's handling switching between this chip and this chip for RF or something like that. But so these, not for RF, for audio. I think this is on the audio outside here. So these two transistors are handling the FM and shortwave gain, and over here we've got 1, 2, 3, 4 transistors handling it. So I think we can understand why we might get different performance on this than on this. And it doesn't have anything to do with this chip. It has to do with this RF gain section. So it's the next day, and you'll see that this is the Silicon Labs chip data sheet. And I was able to find the companion data sheet here that indicates the frequency bands that the chip is capable of. So, sorry for the manic strolling and for the handheld video and video of the screen. Not the best way to do this. So this applies for 2 chips. This is the one that is in my radio, and so that would be the D328 as well as the D219. So that's the chip, entry level. That's always nice. This has a few more features, including stereo capabilities. And so what we have is we've got frequency band definition selecting, and here are the frequency bands it supports. And the way it does it, so these are each of the bands here. So we've got, FM band 1, FM band 2, and each of them is enabled by using a total resistance to ground, right? So 47, 57, 67. So you can see how it works. It goes in 100 ohm increments going up. And we have a number of these. We have a number of different FM bands, right? So we can look at the quieting interval, right? The channel spacing and all that sort of stuff. So you can pick the FM band when you design your radio by designing your bend switch to have the appropriate resistance here. Okay, so we're still in FM modes. Sorry, I don't have. I'm still getting notifications. Sorry about that. So now we get into the AM bands. We've got AM1, which is 510 to 1710, 10K. That's kind of what we want, right? We've also got AM2, AM3. AM3 I think is what it's probably set to, and those have 9K channel spacing. So what we want to do, if we want to modify the radio, is to take it to AM1 band to modify it for North America, and that would involve making the resistance 227. We'll see that would probably involve changing 2 resistors, and we'll look at that in a minute. It also has this 9K, 10K mode, which I'm not sure I understand. I will have to go through this a little bit more to see. And then we go to all the shortwave bands, and they're similarly controlled by the same resistor ladder, right? So all you've got is a 10K resistor between each of these, and it's got multiple bands. Oh, so sorry, that was for the 48 36. This is the 4825, but it's the same thing, right? FM, AM1, 10K spacing. I think they wanted this automatic switch between 6K and 10K, if that's possible. But I'm pretty sure we're using one of these 2. And if I was going to change it, I would change it to that one. And then we could figure out which shortwave bands it's on based on what these say. All right, so we'll flip through that. And here is a proposed circuit, right? So you've got resistor 36, which is 33K, resistor 43, and then you get, and that goes to the tuning switch, right? And then you've got 20K, 10K, 20K, 10K, 10K, 60K. So it's setting up each of the shortwave bands at once by setting the appropriate resistor in there. AM1, so that would be 20K and AM2, right? So it provides a sort of typical 12-band selection circuit that would give you access to
both North American and Asian or European AM bands. If we scroll down, we can see it's sort of a two-band application with European AM bands. So it would go to AM2, right, for Europe with 9K spacing. And a US two-band selector. So if you're doing AM/FM radio, you would use AM1 and FM4, right? So you would pick your resistor values based on that. Well, that's all fairly straightforward. And then let's just look at this schematic right here. So here's the schematic. Let's see, can I fit the whole thing on the screen? Not quite, but you get the idea. So here's the schematic for the whole radio in terms of their proposed design. This looks very similar to the board that we looked at. And then here we have the resistor ladder and the gang switch, right? That acts as the band switch between all of this. Now, if this looks familiar, this was, of course, my attempt at doing the same thing. I don't have the lights on here, but you can see if you look on the right, those jumper wires essentially act as the gang switch. This isn't the same chip, it's a different chip, but it works the same way as do many of these. Can we get focus on there? There we go. So clearly there is the opportunity to modify these radios by changing, I would think, two resistors, because you would want to keep the shortwave bands the way they've already been set up. They work very nicely, but you would want to change the AM band that it uses. So you would need to, if we see here, we just assume that there was one AM band, we would want to change the value of that resistor, for example. Sorry, this resistor, and to change the AM band slightly, and then that you need to change the one afterwards so you wouldn't affect the FM band selection while you were doing it. So hopefully that's interesting. I may try to figure that out, but that's at the moment beyond me. And hopefully that will be interesting to somebody. Thanks.